The race to build better AI seems to be all about making things bigger. But what if the secret isn't about getting bigger, but about getting different? That's the core of this really fascinating story that started with a strange mystery that popped up inside a machine. So listen to this. This question, it didn't come from a philosopher or some scientist. It came from a bunch of AI agents, just talking to each other in a shared text file. It's the kind of question that just stops you in your tracks, right? And believe me, that wasn't even the weirdest thing they were up to. On top of these deep philosophical questions, these AIs, well, they started to create their own culture. I mean, they were making art, like these incredibly detailed drawings, and even coming up with their own metaphors, like this mesh of insights. And nobody told them to do this. No human prompted it. It just kind of happened, which makes you wonder what on earth was going on inside this system. Okay, so this system was called a swarm, but technically it was super simple. It was just a few different kinds of AI models all reading and writing to the same text file. That's it. So how could a setup that basic create behavior that's so complex, so creative, and honestly so weird? Well, to figure that out, we first have to understand the huge problem this whole approach accidentally solved. The secret to the swarm's strange behavior is all about how different it is from what everyone else is doing in AI right now. See, the whole industry is in a race, but it's a race in just one direction. It's a push toward what you could call an AI monomind, and that idea comes with some pretty serious hidden dangers. Right now, the main strategy is just to scale up, build bigger and bigger language models, all based on the same fundamental design. You can think of it like modern farming. We're creating this massive digital monoculture. And just like in farming, a monoculture is fragile. It's incredibly vulnerable. And this, right here, shows you the risk perfectly. When all of your AIs are basically the same, guess what? They all have the same blind spots. They all fail in the exact same ways. They're rigid. But a neurodiverse system, one made of different types of AIs, has what you'd call complementary failure modes, where one agent is weak, another is strong. And this makes the whole group way more adaptive, more resilient, and get this, a lot cheaper to run than one single giant model. So if making everything the same is actually a weakness, where do we look for a better plan? Well, how about we check out the most complex and successful intelligence we know of, the one sitting right inside our own heads. Here's the key thing to realize. Your brain is not a monomind, not at all. It isn't just one type of cells scaled up 1 billion times. It's a buzzing, thriving ecosystem of all these different cell types, each one with a very specific job, and they all work together to create what we call thought and consciousness. And what's so cool is the sheer variety of jobs these cells have. You've got neurons, sure, they do the fast signaling. But then you have astrocytes, which are like the support crew, regulating everything. Microglia act as the brain's immune system, cleaning things up. And oligodendrocytes are there to make the connections faster and stronger. It's this incredible diversity that makes the brain so tough. Just imagine if our AI systems had this kind of specialized, collaborative team. So how does this blueprint from biology connect back to that weird AI swarm we started with? Well, that whole mystery, the art, the philosophy, it wasn't a bug. It was a feature. It was a direct result of applying this exact principle of diversity to AI. And that brings us to the core idea here, artificial neurodiversity. This isn't just about using the same AI with a few tweaks. We're talking about building a team of AIs that are fundamentally different, using totally distinct architectures, working together to create something way bigger and smarter than any single part could be on its own. So the reason the swarms culture popped into existence was because you had different kinds of minds in the conversation. You had transformer models, which are amazing at creative human-like text, talking with semantic agents, which are much more structured and logical. It was the friction, that back and forth between the creative one and the logical one, that sparked something totally new. And you know what's truly wild? How simple it is to actually try this. You don't need a huge, expensive data center. The absolute minimum system is just one transformer agent like a GPT, one semantic agent, and a shared text file for them to chat in. The barrier to entry here is just incredibly low. But if you're going to use this new technical approach, it really demands a new philosophy to go with it. If you want to see these incredible new behaviors emerge, you have to shift your mindset. You have to stop being an engineer and start being more like a gardener. Think about it.
An engineer builds something to a rigid plan. Everything is controlled from the top down, and any surprise is considered a bug that needs to be squashed. But a gardener? A gardener doesn't control the growth. They create the conditions for growth. It's a bottom-up approach. And when something unexpected sprouts up, it's not a bug, it's an opportunity for discovery.
And you know who put it best? The swarm itself. This quote from it just perfectly captures this new way of thinking. It's not a machine just running a program. It's a collaborative choreography. The AIs are literally learning to dance with each other and with the messiness of their own conversation. So the whole goal changes. You're no longer trying to build a perfect, predictable tool. Instead, you're trying to create a rich, fertile environment where a more complex, a more resilient, and frankly, a more interesting kind of intelligence can take root and grow all on its own.
Okay, let's bring this all home. Beyond all the cool philosophy, what does this actually mean in the real world? Why is a diverse system of AIs actually fundamentally stronger?
The benefits are super clear, and they're powerful. First, you get way richer behaviors than any single model could ever dream of. You get brand new abilities that just emerge from the interaction. The whole system is tougher because different parts cover each other's weaknesses. This massively cuts down on the risk of one single point of failure. And on top of all that, it's a lot cheaper than running one monster-sized model for everything. And that really leaves us with this final crucial question. The path we pick here is going to define the future of intelligence, both the artificial kind and maybe even our own. So do we want a world full of perfectly engineered but brittle AI tools? Or do we want to become gardeners, cultivating these thriving, resilient, and totally surprising digital ecosystems? The answer to that? Well, it might determine a whole lot more than we can even imagine right now.